Welcome to qnawire.
All right, so this is a graphical interpretation problem, and in part A, we are asked to find what moment this moving cat experiences its greatest force. Well, this is a plot of velocity as a function of time, so we're first going to have to find the maximum acceleration before we can find the magnitude of the maximum force. Because it's a straight line, it means that there was constant acceleration. We basically want to find the time interval of this graph where the slope is the steepest. And I believe that is the beginning of the graph from 0 to 2 seconds. So in other words, we're going to take the time difference on the bottom, 2.0 minus 0, and then the respective velocities of that interval, which were 8.0 and then also 0 respectively. And so we have found that the maximum velocity over that time interval was 4.0 meters per square second. Good. And then we're just one step away from finding the maximum force. We just go ahead and apply Newton's second law, F equals ma, but specifically for the maximal case. Plug in the mass of the cat, which was given to us as 2.75 kilograms, and the acceleration we just solved for 4.0, and get that the maximum force is 11 newtons. Good. And then they also want us to specify what time interval this occurred over. This was on the time interval of 0, or t is between 0 and 2.0 seconds. Good. So in part B, they want to know the time interval over which the force is equal to 0. So if the force is equal to 0, then that means the acceleration at that point in time was equal to 0, or that the velocity was constant because there is no acceleration. So in other words, the graphical interpretation would be a flat line, and that does occur here, and that is in the middle interval from 2 to 6 seconds. Sorry, 2.0 is less than t is less than 6.0 seconds. Great, and then lastly, cap things off with part C. What was the force over the last interval? Because they want to know what the net force was at 8.5 seconds. So similar procedure to part A, but it's not the maximum force. It's just the force that's being applied in that third time interval. So we do the same procedure. The velocities at the endpoints are 12 and 8. And the time interval is from 10, or rather 6 to 10. But we subtract it off the other way. So this acceleration comes out to be 1.0 meter per square second to two significant figures. And now we can go ahead and convert that into a force by doing F is equal to ma. 2.75 is the mass, 1.0 is the acceleration. And so to two significant figures, that force is going to be 2.8 newtons. And we're done.